As we discussed before, the speed of sound in water is not a constant parameter, and there are many factors which may influence on the acoustic signal which is propagated in water column. Among those factors we have next main as a temperature, pressure, density and salinity. And a few more details, just nice to know, I will provide you right now to understand better why the speed of sound in water is different at different operational depths. So changes in temperature can give you the increasement of speed of sound in water. We have increasement per 1 meter per second when the temperature changes achieve 0.24 degrees, and in that case the lower the temperature, the higher speed of sound in water. Pressure at a rate of approximately 1 meter per second per 60 meters may increase the speed of sound in water. Density, so if denser the environments, then the higher speed of sound in those environments. For example, the speed of sound in marble is about 5000 meters per second. Salinity at approximately 1 meter per second may increase the speed of sound per increasing of salinity per 1 divided per 875 part. The speed of sound in water is one of the most critical and ultimately limiting factors in the potential accuracy of acoustic positioning systems. Seawater is not a uniform isotropic medium. The velocity of sound in water is affected by listed factors. Remember that. For that reason, some systems as a long baseline requires to be calibrated before start up the using of the system. And when I say calibration, it means that a special vessel arrives in location and install the test beacon. Then at the distance 1.5 of the depth away of the beacon, the vessel make circles for estimated period of time, checking the response of the beacon, and salinity also checked with the samples on different depths, and then a special calibration file created to determine the speed of sound in water in that specific location, and this calibration file should be provided to the fleet which is going to use the HPR equipment in this area, and this file must be downloaded to your HPR station. Otherwise, the system will not be able to produce the correct calculations. Also, guys, we have to highlight the set of negative factors which may influence on the quality of the signal propagation in water for your HPR system. Among those factors we have noise, which may be produced by thrusters, ship, drilling and diving, waves and other HPR users, and reflections from the sea bottom, vessel, surface or subsea structures. Ray bending, which may appear due to temperature layers through which the signal goes, and salinity, which is different on different water depths. Transmission loss, which is accompanied by spreading and absorption of the signal. Those listed factors may reduce the quality of the signal produced and accepted by HPR equipment, and that should be taken in account by the DP operator. When the SIP beacon installed at the bottom, we need to keep in mind some precautions. HPR transducer may suffer from the noise produced by open vessel thrusters and main propulsion. And please remember or mark somewhere low thruster RPM make more noise for HPR system compared with the higher RPM. Always, if operational conditions permit, vessels should keep the HPR buoys or transporters in upwind upcurrent position when environments blow away the noise. This is a general recommendation about installation of the sea bottom beacon and the relative vessel position during the operation with the use of HPR. Guys, we know that there are no ideal systems or there is no ideal equipment in the world, and any equipment has pros and cons. And whatever we discuss here, the main our target is to show you the advantages and disadvantages of equipment in use, and then you will be prepared to make your personal choice when you select a certain type of system for yours. And from my point of view, it is very important to know advantages and disadvantages of available equipment when you are the one who makes the decisions at the bridge. Long baseline system has the next advantages: highest potential accuracy, one hydrophone needed only, redundant data from the system, and normally the system uses from 3 till 12 beacons at the same time. For normal operation, enough at least 4. The system may operate with the 3 beacons, but recommended to have at least 4. But if you have more than 4, it means you are more redundant. But there are some disadvantages for long baseline. It requires multiple seabed transporters, long data update intervals, and each site calibration and redeploy is needed. Expensive maintenance, expensive beacon installation, and so on. Short baseline system has good accuracy, requires a single subsea pinger, one-time calibration needed only. Accuracy depended on BRU or MRU, that is the module which measures pitch, roll and heave, and a heading sensor. Multiple hydrophones required through the hull. The ultra-short baseline system has also good accuracy. This is modern solution. Requires only a single subsea pinger or transporter. One-time calibration only needed. Highest noise susceptibility, that one is a disadvantage for the system. Accuracy depended on VRU. And as you see, we don't have the ideal equipment, as I said you at the beginning. Always we have some pros and cons, whatever we use here.